Welcome to this lecture on graphic user interfaces in Python. Now, if you want to, there are reasons to set up a traditional graphic user interfaces. Native interfaces have advantages over web interfaces, at least in the past. Today, you can make a highly effective web interface, so the use case for a native GUI is somewhat smaller outside of cell phones. And Python is not a good language for building user interfaces outside of web pages. Now you do have options on Windows. You can use TLC and Tinker, which is a set of standard Python libraries for making buttons and text boxes and traditional user interfaces. Qt also works under Python. Both work well, but are not worth teaching in the course due to limited use cases. Notebooks have replaced traditional GUIs for scientific applications. If you need OS-specific forms in Python, both work well, but I'm not going to spend much time teaching them. Python is not interface first, and this is my point of view. There's no built-in standard interface. Python is focused on scripting. It allows flexibility. Historically, C++ or C# was highly integrated into the .NET framework. C++ and C have supported multiple user interfaces. JavaScript was designed for controlling web pages, the document object model in your web browser. JavaScript have had several frameworks that drove the language for constructing graphic user interfaces. Not as much true today. Python avoids excessive boilerplate by minimizing the role of the user interface. It's really designed for the model. It is part of the model view controller architecture. So Python really is the model and works best when you have something else that does the graphic user interface. If you're in .NET, or .NET framework for Windows applications is the best, C#. Swift and Object-C for iOS, Kotlin, Java, and C++ for Android. Dart is good for cross-platform. Blazor is an interesting choice for C# in the browser. React and other frameworks for the web, mostly JavaScript and TypeScript. Native applications are developed for specific devices, and they take advantage of the device. So web page applications are built like web pages, but they look like applications. It's a small application that basically points to a website. Native applications tend to work better without network connections. And then you have hybrid applications that are advanced web applications that have a nice container and some native features. The line is blurred between a native and a web application. So today you can develop a web application that gets close to the performance of a native application that's written for that particular operating system. I need a graphic user interface for my project. And this is my viewpoint. Others may have different ideas. The number one rule is don't fight the tool. If you're making a web app or an app for your cell phone, don't use Python. It's not designed for that. It can work for the back-end code, but it can't really do the user interface part. So what I would suggest is try these things sort of in order. Use a notebook interface. If that works for your user, it works. So if your user is a sophisticated user, you can set up a notebook, hide sections of the notebook, and it works great for scientific applications. Use a web interface with Flask. Write a microservice that's in Python and do the graphic user interface in a native tool. Consider Qt for very specific examples. So if I have a machine control interface written in Python for some good reason, I'm not even saying Python would be good for that application, but let's say I needed to do some image processing, wanted to use Python for that, was doing 90% of the work in Python, then I might resort to Qt to give the user a graphic interface. Now this is one of the shortest lectures in the course, and the reason why is that going through Qt doesn't really add much benefit. So with that, I'll conclude today's lecture. No quiz on this lecture.